Okay, section 3.6 is on rates, and rates are actually really similar to ratios, which we did last day. So let's get right to it. What's a rate? A rate is a comparison between two numbers, so that's a ratio. It's basically a ratio, but it has different units. That's the key. That's the difference between a ratio and a rate. And only whole numbers are used. You don't want to have any decimals when you write your rate. So let's take a look. What is the rate if a car travels 360 kilometers on 25 liters of gasoline? So you can see we're talking about two different units here. We have our kilometers and we have our liters. So the way you could write this is one of three ways. You could go 360 kilometers to 25 liters. I would say that's not as common to write a rate with 2, but you could. You could write 360 kilometers colon, remember that means 25 liters. That's very common. And perhaps the most common when you're talking about rates is the fraction method. So remember we can write as a fraction, so 360 kilometers over 25 liters. So I think I'll write it that way. And you know what I'm going to do? I'm going to shorten liters to just L. You're clear that L, capital L means liters. So just like with ratios, we like to put them in lowest terms. So this right now is not in lowest terms. What can we divide 360 by and also 25? Well, they end in 5 and in 0, so I know I could divide them both by 5. Why don't we do that? We'll divide this by 5 and we'll divide this by 5. So the bottom's no problem. 25 by 5 is 5. And on the top, we have 360 by 5. It's a little bit more difficult. It's 72. So there's your rate, 72 to 5. But wait a minute. With a rate, you actually do need to include the units. With a ratio, you didn't, because remember, the units were the same. They canceled out. You can't cancel out kilometers and liters because they're different. So it's 72 kilometers and 5 liters. That's your rate. The rate is 72 kilometers to 5 liters, or 72 kilometers per 5 liters. We often use the word per when we are talking about a rate. Now that might look a little funny to you, 72 kilometers to 5 liters. That's because we're going to talk about in a second this idea of a unit rate. So let's just sit with that for a second and we'll get back to it. Alright, what's the rate if a car travels 243 kilometers in 6 hours? So again, we have two different units. We have kilometers and we have hours this time. We're comparing distance and time. What did we compare last time? We compared distance and volume, the amount of gas. So this time it's distance and time. Same sort of thing. We're going to go 243 kilometers. Decide which form of the ratio you want to do. What the heck, I'll do it this way this time. To 6 hours. And we want to see if we can put this in lowest terms. What can we divide both of these by? So you could divide both of these by 3. So let's do that. So the second one is going to be 2, and we do have to include the hours. And the first one is going to be 81, and we do have to include the kilometers. So there it is. This is our rate, 81 kilometers in 2 hours. And the one we did up here was 72 kilometers to 5 liters. Now, this, I'm thinking, hoping even, that this will sound weird to you. If I wanted you to tell me how fast the car is going, and you said, oh, the car was going not that fast, it was going 81 kilometers in 2 hours, or 81 kilometers to 2 hours, or 81 kilometers per 2 hours, it just sounds weird, doesn't it? And the reason for that is because when we express rates, we usually do it as a unit rate. And what a unit rate is where a rate in which the second value is 1. And in this rate, the unit rate, you are allowed to have decimals in the first value. So if you look now, I have the same questions as above. Actually, I've done this incorrectly because what I meant to do is actually to write what is the unit rate if a car travels blah, 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 and what is the unit rate if a car travels 243 in 6 hours. So it's exactly the same questions as above, except it now asks for the unit rate instead of just the rate. So let's go back up and look what we got as our answer. For the first one, we ended up with 72 kilometers per 5 liters. So let's start with that. I mean, we could start with the 360 and the 25, but obviously it's going to just simplify down to 72 kilometers and 5 liters. So I'm going to write that to start. 72 kilometers 5 liters. Okay, now what we would like is we want for a unit rate, we want this second value, the liters, we want it to be 1. We want to make this so it's like this, just 1 liter on the bottom. How are you going to do that? The way it works to get a unit rate, you can always just take the top value and divide by the bottom. Or if you want, look at this, you could cross multiply. You go 72 times 1, which still equals 72, and divided by 5. Either way you're doing it, you're doing 72 divided by 5. And 72 divided by 5 is 14.4. 14.4 what? 14.4 kilometers. So now we can figure out that the amount of gas that the car uses is 14.4 kilometers per liter. That's more useful than 72 kilometers for 5 liters or 360 kilometers for 25 liters. This is the most useful. And in fact, the way we often write that, once we've got a unit rate, we often write it like this, 14.4 kilometers. Then we put our, this line right here, but we put it like this. And instead of putting 1 liter, we just write liter. And that means 1 liter. So this is 14.4 kilometers per liter, or per 1 liter. Right? That's the way it's often written. Alright, let's try the second one again. We had gotten it down to 81 kilometers in 2 hours. The speed of the car was 81 kilometers in 2 hours. But again, we don't want it to be in 2 hours. We'd love it to be a unit rate and have that second number be 1 hour. So how do you do that? You take the first number and divide by the second. Even if it gives you a decimal, that's okay. And if you do 81 divided by 2, you'll get 40.5, and it's kilometers. So you get 40.5 kilometers per 1 hour, or 40.5 kilometers per hour. Again, I'm sure you're used to seeing something like that, kilometers per hour. So there's all sorts of rates that compare 2 units, right? Meters per second. Dollars per year, maybe if you're looking at profits or something. Centimeters per day, you're looking at how fast a plant grows. We could go on and on looking at these things. The last concept I want to look at today is best buys. So best buys are when you compare prices in order to save money. I mean, it's a smart thing to do, right? It's best not to just walk into the store and buy anything. It's good to take a look and figure out what would be the best option, the best price. Now, in order to do this easily, if you find the unit price, which is just like the unit rate, then it's going to be very easy to compare them. So remember, unit rate means 1. You want to find the price of one object, in other words. And of course, it doesn't mean just because something has a lower unit price, it doesn't mean it's better. If I went and I found I could get 1 bottle of ketchup for $4.62 for 1 bottle, or I could get 50 bottles of ketchup for $150, that's definitely a lot cheaper to get 50 for $150. But why would that might be a dumb move? Because I don't think I'm going through 50 bottles of ketchup in the next year or so, and they'll probably all go rotten by the time I get to them. So you want to think about things like the quality. Maybe the cheaper one isn't as good. The expiration date. No point in buying stuff if it's going to go bad. And storage space. Where on earth am I putting 50 bottles of ketchup? So there are things to think about besides price, but for today we're just going to look at price. For example, here is, I don't know what we're buying here, but you can get 2 of them for $2.98, 4 of them for $5.68, and 5 of them for $11.52. We want to know what the best buy is. Now, often the best buy is the one that's the most, right? If you buy 5, it's often the best buy. But that won't always be the case in these questions. So we need to find the unit price. How do we do that? To get the unit price, in fact, maybe I'm going to do that up here. I'll give you a little formula. Unit price equals the cost, C-O-S, and look at how clever I am making that a dollar sign. The cost divided by the number of units or number of items or whatever. Okay? That will always give you the unit price. So you take cost and divide by the units. So in this case, if we want to know the unit price, I would take $2.98, which is the dollar amount, and divide by how many there are, 2. And if I divide that, I get $1.49. Now I need to put two units down. Dollars per what? Per unit. $1.49 per unit. Okay, if I want to get the unit price of this, I would go $5.68 and divide it by 4 this time. And that equals $1.42 per unit. And the last one, if I took $11.52 and divided it by 5 units, I get $2.30. Always round it to 2 decimal places because we're talking about money here. So which one's the best? Now be careful. Sometimes people see this big number and they say that's the best. But we're trying to save money. You actually want the one that is the lowest. So actually the best price is this one, the $1.42. So this option right here is the best buy. I don't know what's going on with this last one. It's pretty expensive. It must be super quality, organic or something. I don't know. I don't know what the item is at all. By the way, I just want to make a point. If you do it in the wrong order, let's say that you actually, for the first one, you divided 2 by the 298. I just want to show you that you can still compare them. It just is a little bit more awkward. If I go 2 divided by 298, you get 0.67 if I round it to 2 decimal places. Now be careful, that doesn't mean $0.67 or 67 cents per unit. When we divided this, it was 2 units divided by $2.98. So here, similarly, it'll be 0.67 units per dollar. So what's that mean? It means for every $1 you spend, you can buy 0.67 units. Now that's not very realistic. You can't go into a store and ask for, put down your dollar and say, give me 0.67 units. But you can use it to compare. For example, if I now looked at the second one and divided 4, which I don't recommend, but if you did this, 4 units divided by the 568, you'll get 0.70. Again, that's 0.70 units per dollar. Well, if you put $1 down, would you want to get more or less units? You'd want more. So again, the second one's actually better. In this case, you'd be looking for the bigger number. So I find that more confusing. It's not very common in the world that people look at things this way. So I strongly recommend you always take your dollar amount and divide by the units. Alright, one more. Tina wants to buy a jar of pickles. Oh, good for her. My favorite thing, pickles. Jar A contains 1.2 liters of pickles and costs $3.60. And jar B contains 1.6 liters of pickles and costs $4.72. What's the better buy? Well, it definitely would depend on brand. Let me tell you, there's some good brands of pickles out there. Talk to me if you're interested. But if we're not worried about maybe they're the same brand, we just have to do our unit price. So how do we do it? Take the dollar amount, so for jar A it's $3.60, and divide by the number, in this case the amount, which is 1.2 liters. And if you divide that, you get 3 exactly. So it's $3, that's what was on top, per liter. $3 per liter. In jar B, the dollar amount is $4.72, and the amount is 1.6 liters. If you divide that, you get 2.95. So again, that's dollars. We divided dollars by liters. So it's $2.95 per liter. $3 per liter or $2.95 per liter? What would you rather pay? Of course you'd rather save that 5 cents. What a victory for you. So jar B is the better buy because it's cheaper. It's a smaller number here when you get the unit price. Alright, so that's the idea with rate and unit rate and best buy. I hope it makes sense, and if not, let me know. Take care and goodbye.